One way that we can improve the performance of our models is through cross-validation. So far we have used split data, which gives us one training set and one test set. We have used a 70-30 split. In cross-validation, we use multiple training sets. The data is divided into n folds, or subsets. We then train n models. For each model, one of the subsets is set aside for validation. This is called the holdout fold. We then train the model on the other n-1 folds and validate against the holdout fold. So if we had 10 folds, we would train 10 models. For each model, we would use 1/10 of the data for validation and the other 9/10 for training. We would then shuffle which 10th was used for validation and the other 9 would be used for training. After we train all of our models, we evaluate and combine the results of each model into a single averaged result. There are several advantages to using cross-validation. The first is that we use our entire dataset for both training and evaluation. Using the split data module, we were only using 30% of the data for evaluation. If for some reason this data were not representative, then we might not get the best results when we evaluate the model against this test set. Using cross-validation, we use all of the data for both training and testing. In this way, we are really evaluating the dataset as well as the model. Cross-validation can help indicate how representative the dataset is, and also how sensitive the model is to variations in the data. To begin, I have copied our linear regression experiment. Let's replace the linear regression module with the boosted decision tree regression module. After running the experiment and visualizing the results, we can see that all of the metrics have improved over the linear regression. The coefficient of determination is now 0.37. Let's see if we can use cross-validation to improve this result. We will remove the split data module and add the partition and sample module. We then select the partition and sample mode. In this case, we will select Assign to Folds. We will use a randomized split, and we will specify 10 folds. We have the option of specifying a stratified split. A stratified split will evenly divide the rows by some key column. But for this experiment, we will leave this value as false. We will remove the train model and score model modules, as they will be replaced by the cross-validate module. I do not actually need to use the partition and sample module here. I could directly connect my dataset, and cross-validate model will by default create 10 folds. However, I wanted to introduce the partition and sample module, as it is useful in a number of contexts outside of cross-validation. And finally, I connect the output of cross-validate model to the input of evaluate model. After running the experiment and visualizing the results, I see some modest improvement in all of our metrics. The coefficient of determination is now 0.386. These results tell us two things. First, that our model can have some small improvements with additional training sets. And second, since the improvements were fairly minor, we can be confident that our dataset is representative.